Next up, we have oral presentation 10, Moreno Valley, California, Mission 12 Flight Experiment.
Good morning. We are the student team selected for flight on Mission 12 from Valley View High School in Moreno Valley, California. All four of us are principal researchers, as we did want to take a big part into this experiment. I would like to introduce myself. I am Roman Lara.
I am DJ McCormack.
Title Lam.
My name is Samaj Martinez.
And Deepika Srivastava is our project director for Moreno Valley Unified School District. Mrs. Katzenstein is our facilitator, and Ms. Johnson is our school principal. Our experiment is titled The Effects of Microgravity on Soybean Germination. And here are just the names listed out for you. And this is our project summary. In all, we are sending up 2 soybeans, and these soybeans will be tested to be germinated in microgravity. And after we have gotten the results back, we will observe the root structure development of the actual soybeans themselves and the roots coming out of them. We will accomplish this using a microscope to observe a cross-section of the actual roots itself. And the growth of the soybeans will be measured in the metric system using a centimeter ruler, and this will be compared to the actual length of the soybean growing on Earth.
Some background research about the soybeans was that it takes about 2 days on average for them to sprout. And during this time, they're the most vulnerable, to things like temperature changes in the soil, blight, and not sterilizing can cause the seeds to rot and to form over time in extended periods, hence why we froze them in hopes that they survive the trip to the ISS.
The materials that were used for the experiment follow the structure of the Type 3 FME with three different volumes. The first being the 2 soybeans enclosed are sandwiched between cotton in order to help the seed grow by providing a medium that allows the roots to settle into. The second volume being the water, which will be released and absorbed by the cotton in order to be a sufficient water source and continuous source for the seeds. The next volume would be the alcohol, which will be a killing agent for the soybeans.
The sterilization process for the soybean seeds will be to submerge them in 3% hydrogen peroxide and set the heat to 140 degrees Fahrenheit. We will submerge the beans in the hydrogen peroxide for 5 minutes, and then once we take them out, we will dry them and we allow them to cool, and then we will peel the skin off of the soybean seeds, and then we will refrigerate them for later use.
Our pre-flight procedure, which was just our procedure before the actual flight, after we had been told that we were going to be participating into this mission, we were preparing the FME for the payload and the sterilization of the soybeans itself, and preparing the FME and going along with the NanoRacks conference to actually professionally load the FME to make sure that there is no room for mistakes in any way, shape, or form. And as we had previously stated, we were loading the FME with specific volumes, which we will mention later. And we made sure to seal and label the FME and prepare the FME for the shipment, which would be the handover. May 29th through June 12th was the handover window.
Our flight procedure is that once our experiment has flown, we will begin by conducting the ground truth experiment at the same time as the onboard experiment. In this time, we'll be monitoring the astronaut interaction throughout experiment days, and to conduct the exact same interactions on Earth, we have a similar FME as when we were sending to ISS that was assembled under the observation of NanoRacks. The experimentation and interaction days will continue until the experiment has concluded.
Once the experiment is received, we will observe the effect of microgravity on the soybeans in comparison to the ground truth experiment. The length of soybeans will be measured with a ruler by centimeters, and we will use a microscope to compare the root structure development of the soybeans. Afterwards, we will organize our data and report our findings.
Our events are, the launch will be held tomorrow, June 29th. And on July 30th, the projects will land, and they will splash down in California off the Pacific coast.
Our conclusion is that as of today, we can't exactly make empirical statements about our experiment because we have not gotten the experiment back, nor has it flown. As a team, we have made a hypothesis, however, and we believe that the cellular structure of the actual soybean root will prove to find that the cell walls will begin to expand as compared to the soybeans grown down here on Earth because of the unneeded stress and unprovided stress up in microgravity. In conclusion, we will compare these results once we get them back and see if there any further research can be done to provide any information needed with the inspiration of the Mars colonization race. And I would like to give a special thanks to the University of California in Riverside, to the California Space Grant, Karen Johnson, our principal from Valley View High School, Dr. Martin Rex Kadziora, our superintendent of schools in MVUC, and of course, Dr. Jeff Goldstein. Thank you.
Do we have any questions for this team?
Hi, I'm Jordan from Sanford, Connecticut, and in regards to the root structure, how would you analyze the root structure to effectively say the growth of soybeans is good or bad? How would you use that data?
Once we actually get our experiment back, like I mentioned, we will be taking a cross-section and observing these under a microscope. After that, we will see if there's any change or any things done to the actual cells themselves, the individual cells, to see if anything has been damaged, possibly, or if the cell walls were broken, or if anything was void to the actual growth of the soybean.
Okay, thank you.
Julia from New Mexico. So I was wondering, so the focus of your experiment is soybeans, and is there any particular reason why you chose like that plant? As like we've seen the ISS, they've worked with radishes, lettuce. Is there any particular reason why like soybeans is what you're focused on?
So I'm sure you've heard around that first we went to to the moon, and we went to space, and now Mars is becoming an idea, colonization. And well, we need food, don't we? And with a soybean, that we have production of oxygen as well as a source of food, and many products are using soy as their one of their main ingredients, and this could contribute to the actual production of many foods or products that require soybeans. And that's why we chose soybean.
Okay. Thank you.
Thank you, guys.